you have to use your protractor, you have to use the compass, but we can't do that now. We'll use computer to do this one. So the first thing is to find the total frequency. Number of children is the same as the frequency. So the total frequency is 210. So a pie chart is drawn in a cycle. Hey, the noise has started again.
Yeah, Emmanuel Kumsi, kindly off your mic. Emmanuel Kumsi.
Okay. All right. So when we're doing the relative frequency, we're multiplying by 100. But now we are not going to multiply by 100 because we are taking everything into a circle. And total degrees in a circle is 360. So instead of multiplying by 100, we are now going to multiply by 360. Now, so we are going to have 75 dividing 210, and you multiply by 360. So we say 75 in that cell divided by 210, and everything will multiply 360. You have that. So this one is in degrees, 128 degrees. Let me approximate to the nearest whole number. So this will be 129 degrees. So when you take your compass, your mass set instruments, you should be able to construct your 129 degrees. You do the same for all of them. So you do the same thing here. 57 divided by 210 times 360. So at the end of the day, okay, you do 78 over 210 times 360. At the end of the day, when you total all this one, it should give you 360 degrees, which is the total, I mean, the degrees that the total degrees that a circle has. We have in a circle. Just as when you do the relative frequency, you add all the percentages and you get 100. Now we are talking about 360. However, you can just use your computer this way. You select it the way you are seeing it. Then you go to insert. Then you have a pie chart here. So you click on the drop down arrow and you select this one. So you can see your pie chart beautifully drawn, where the green color represents fully immunized. This one partially immunized, and here not immunized. Here you have a lot you can do if you want to show the data. This is just an additional knowledge for you, how to use your computer to draw a pie chart when you have a set of data that you want to make it simple to understand. All right. Now we are going for any question about the pie chart? Any question about the pie chart?
Please, can you go over how the insertion was made? I mean, on the Excel.
All right, I'm going back there.
For Sunday school, they can include the schools.
Okay, so I'm sharing the Excel sheet. So you have your data.
150
You have your data here.
was children.
All you have to do is
Madam Mercy, please mute your mic. Madam Mercy, please mute your mic.
Yes, okay.
you select the data the way you are seeing it, including the total. Then you go for insert at the top here. When you go to insert, we'll be talking about histogram and code. They are also here. But for now, we are talking about pie chart. So you click on the drop down arrow here. You have the donut, you have the pie, and you select this one. Once you click on it, you see your pie chart beautifully drawn for you. So easy. Any question? Any question?
No, please, can you go over again?
Hello, Doc.
Yes.
Hello, Doc. Yeah. My question is, assuming you don't have a laptop or computer and you are using the phone, how can you do what you just did and also have the five-star design aspect? Thank you.
Okay. If you don't have a computer, then you have to go the manual way at best. To use phone to do this, personally, I don't like using phone to work on databases, even documents. I hardly use phone to read documents. I prefer to see it on a bigger screen like laptop or the computer. So if you want to do this on phone, you are going to waste time needlessly. You are going to waste time needlessly. Maybe you can have time to search on how to go about it. But by the time you do it, maybe somebody going the manual way and finish his or her work before you get yours done. So we are in a world of computers, and you are working, so you should be having computer. By now, if you are an enemy to the internet, you are enemy to the computer, then you are far, 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 far. You are years behind the whole world. I mean, decades behind. So you have to be abreast with time. I hope it's clear.
Yes,
So
sir.
somebody said I should repeat again. I will repeat for the last time. Okay, so you have your data set. Let me just add more. Maybe this is A, this is B, this is C. Come on. Or let me even add the fifth one, E. you have this data set. And at a glance like this, you find it difficult to tell which one is bigger or which one is smaller or whatever. So you want to put it in a picture form. Now, for you to use pie chart, the variables should be up to 5 at where is 7. Beyond 7, it looks so clumsy that it's better to use a histogram or a bar chart. So if you have this data set you want to illustrate in a pie chart, just select here to the frequency, to the last variable and its corresponding frequency. Once you do that, go to the top here. This is in Excel. Look for Insert and come to the charts window. We have the charts here. So the pie chart is just here. Click on the drop down arrow and select your pie chart. So here you can see all of them. The color that is representing which alphabet is in the legend here. And when you go here, you can decide to show the data there. So at a glance, you realize that the one with 55 is the highest. I think that is D. D is the biggest. It has occupied, I mean, the area that it has occupied is the largest. So maybe you have malaria cases, you have hypertension, you have typhoid, you have the various diseases. And you have a data on all of them. You want to see which one is highest, which one is lowest. Maybe you are considering resource allocation. I'm repeating it again. You're considering resource allocation. So you want to see which one should take the chunk of your money or the resource, where the resource, majority of the resource has to go. So you do this thing and you'll be able to identify which one to take how much. Or you want to communicate that information to your clients, your stakeholders, or whoever that needs it. When you do it this way, it's easier understood than when you have the raw figures there. We'll be talking about others too. So I think this is okay for now. So let's go ahead. Yeah, so we're also talking about cumulative frequency. Cumulative frequency. So let's see how we will draw that curve too. A distribution of 50 cases reported at Lekman Hospital in January 2021. Frequency percentage equals to frequency over total frequency times 100. That is fine. It's something we have been talking about all this while. So here, I try to suggest that you have $2,000 and you want to use it, you want to spread it or spend it on these 4 diseases. How do you do that? You have your frequency. So yours is to find the, so this is January 2021. These are the number of cases that were reported. all things being equal, you have to allocate the resources proportionally. So when you want to know how much of your $2,000 you are going to spend on the malaria, is going to be the 18 cases of malaria over the total cases of diseases reported times 100, and that gives you 36%. So that 36% will multiply your 2,000, and you are having 720. Just as we did the pie chart, instead of multiplying by 100 first, you can straight away multiply by 2,000. It will also give you a very good result. So this tells you that you have to spend $720 out of the $2,000 on malaria, $200 out of the $2,000 on diabetes, $480 out of the $2,000 on fever, and you spend $600 on TB. This is how useful relative frequency can be for the work you do. Any question about this? Any questions? Okay, I'm moving away. The same example is done here, relative frequency. So it helps a lot.
Madam Mercy, please mute your mic. Madam Mercy, please mute your mic.
Construct a group frequency distribution table for the data on the amount. Okay, this is the same work we did earlier. This is the same work we did earlier. That's fine. There's something else here. Okay, good. Cumulative frequency.
Sir, please, can we go over this one?
Which one?
Because the last, yes, this question. Can we start from stage 1 to finish? Because the last time we tried to record, but we couldn't done that. So we couldn't do that. So if we can use this opportunity to restart this one so that we can get the whole show together. Because
are you talking about this?
Several people.
Are you talking about this very one?
Yes, this very one. So if we can start from 1 to definitely, I think it will help some of us. The reason is, of course, I'm about 3 people to show me. They all told me that they couldn't get it. So I think if we can do that,
I just explained this one. We just did this one in the previous slides. So I'm saying the left-hand figures, the left-hand side figures are the lower class limits. The 20, the 30, the 40, the 50, the 60, they are the lower class limits. The 29, 39, 49, 59, 69 are the upper class limits. Then we say the class midpoint, add 20 to 29 and divide by 2. In other words, find the average. Find the average of these two numbers. That gives you 24.5. 29 plus 20 divided by 2 gives you 24.5. The reason we are finding this class midpoint, we are going to meet it ahead. So I'm taking my time to explain it well. Now, here to 30 plus 39 divided by 2 is 34.5. 40 plus 49 divided by 2, 44.5. 50 plus 59 divided by 2 will give you that 60 plus 69 divided by 2. That's boundaries. In brief, all the lower class limits subtract 0.5. How did we get a 0.5? One, we realize that it's a uniform class. The class size remains the same throughout. We have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 10 different elements in that class, in this class. So the class size is 10. When you come here, there are 10 different numbers there. The class size is 10. The class size is 10. All are 10, 10, 10, 10. So we have a uniform class. So when you add the upper class limit here to the lower class limit here, 29 to 30, and divide by 2, you are going to get done. When you find their difference and divide by 2, you are getting 0.5. You are getting 0.5, and that 0.5 is what we are subtracting from the left hand side and adding to the right hand side. That is, if you find the difference and divide by 2, or if you add this 29 to 39, you are getting 59.5. When you divide by 2, you are getting 29.5. That 29.5 becomes the upper class boundary for this class, 20 to 29, and becomes the lower class boundary for 30 to 39. So you can see it here. The 29 here is the upper class boundary, and it is become a lower class boundary in the next class. You do the same thing throughout. I think I explained it last week. I have explained it again today. Is there any confusion anywhere to be cleared? Any confusion again to be cleared? Okay.
Yes, I think it.
Good.
No, please.
Thank you. Okay. I'll drop the cumulative frequency curve so that when we do grouped data, then we'll do the cumulative frequency curve. Let's go on with measures of central tendency. So we have the mean, we have the median, and we have the mode. You have forgotten, and I'm going to remind you patiently. So when we see the mean of a set of data is the average of that set of data. And when we say the average, what do we mean? We mean that you add all the data elements. You add all the data elements and divide by the number of them. Good. I thought my screen was. So for ungrouped data, we have this 3, 2, 6, 5, and 4 as a set of data. This could be the years, the ages of children that visited your facility. And we want to find the average age, the mean age. What do? You add all the ages, 3 plus 2 plus 6 plus 5 plus 4. And the final answer will be divided by the total number of data elements. So we have 3, we have 2, we have 6, 5, and 4. How many are they? There are 5 numbers here. So when you add all of them, you are getting 20. Now, when you divide 20 by the 5, you are getting 4. So 4 is the mean of all these data sets, is the average. Any question about that? Or I've just reminded you of your senior high school. Okay.
Well noted,
Sir,
sir.
sir,
Thank
please,
you.
I want to ask something.
Ask.
Please, is it that the mean and the average are they the same? I want to know. Please.
Yes. Yes. We have different kinds of mean, but I'm not taking you there now. We have the geometric mean, we have the arithmetic mean, and the third one, I've forgotten the third one. And there are instances where you use each of them. But let's remain here and make use of this one in our field. So mean and average. You find the average of a set of numbers. You find the mean of a set of numbers. Any other question? Average is just general. I mean specific. Okay, so that is that. Now, okay, so the first value here, we say these are variables. If we say the variable is represented by x, x1, meaning the first number in the data is 3, x2 is 2, x3 is 6, x4 is 5, and x5 is 4. It's just telling the position of the numbers. That's the meaning of what you have here. So the mean is the sum of the xi's. The I represents the first one, the second, the third, the fourth, the fifth. It's also a variable change value. So it's telling you that we are summing all the xi's, and divide by the number of them, n. Example, the data represent the number of days off per year for a sample of individuals selected from 9 different countries. Find the mean. So we have 20, we have 26, we have 40, we have 36, we have 23, we have 42, 35, we have 24, and 30. How many numbers are there?
9.
Good. So 9. You add all of them and divide by 9, and you have your mean. This is nothing you should worry so much about. I'm sure you have already started remembering those days. We have another set of numbers here: 3,782, 6,006, 367, 9,002, 4,208, 6,843, 11,008. When you have to find the average, you add all 6 numbers and divide by 6. Now, you observe something here. If we want a number to represent all these numbers, last week I made mention of a word, an outlier. If we want to use a number here to represent the whole set as the average, we are having 3,007, 6,000, 9,000, 4,000, and 6,000, then 11,000. Okay, here 11,000 may not be too much an outlier, but assuming we have something like 20,000, 40,000 as one of the values, obviously that is too large. That number is too large. So use it to calculate the mean, and you have to use the mean to take any decision. You are going to have a wrong representative for the whole set of numbers. I mean, you are going to get something that will be higher than what would have been used. Let's assume that these numbers here are your salaries at the end of a month. 3,007, 6,000, 9,000, 4,000, 6,000. Then instead of 11,000 here, we are having 40,000. And we are saying, let's strike average. When we strike average, that is how much everybody will contribute for whatever. Because of that 4,000, the average you are going to get is going to be too large. It will not be a real average. It's only one person, the one who earns the 4,000, is the only one that will be comfortable with whatever average you are going to calculate. So in that case, you do not use the mean. You'd rather use the median. And we are going to talk about median. So whenever you see a set of data and there is an outlier, a number that is extremely large or extremely low, do not use the mean to take any decision. Rather, go for the median. So what then? Okay, so we have examples here. Now, we have a set of data. This is a frequency distribution table. We have 5. We have ages, we have the frequency, we have the X. I'm going to show you how we get all. So the data that we had says 5 occurs twice. Those who are 5 years old, they occur twice, or there are 2 people who are 5 years old, and there is only 1 person who is 6 years old, 2 are 7 years old, and 3 are 8 years old, 4 are what? 9 years old, and we want their average. We want their average. And we said earlier that to get the average or the mean, you have to add all the data sets. So for us to do that, we have to add 5 twice. That's 5 plus 5 plus 6, then 7 plus 7 plus another 7, then plus 8 plus another 8 plus another 8, then plus 9 plus another 9 plus another 9 plus another 9. That's all the numbers. That's the meaning of the frequency here. It's telling you that 5 occurs, we'll add 5 twice. 6 occurs once, we'll add 6 once. 7 occurs twice, we'll add 7 twice. 8 occurs thrice, we'll add 8 3 times. 9 occurs 4 times, we'll add it 4 times. But instead of doing that thing like that, assuming 5 occurs 10 times, are you going to do 5 plus 5 plus 5 plus 5 plus 5 plus 5 until you add the 10th one before you continue with 6, 7, 8, 9, and 10? There is always an easier way. When you construct a frequency distribution table, the ages are represented by X. It can be weight. It can be even the diseases. malaria, and co. It can be the diseases. And how many times each of them occurs becomes your frequency. Now, instead of doing 5 plus 5, what do? We use 5 to multiply the number of times they occur. 5 occur 2 times. So 5 times 2 gives you f of x, 10. The f of x means you are multiplying f by x. And this is your x, and this is your f. So 5 times 2 is 10, which is the same as the 5 plus 5. 6 is only 1, so 6 times 1 is still the 6. 7, we have 2. So 7 times 2 gives you 14, which is the same as 7 plus 7. 8 occurs 3 times, and that should be 8 plus 8 plus 8. Instead of doing that, we say you do 8 times 3. You have your 24, the same answer. And 9 times 4 gives you 36. So when you add all the figures under f of x, you are going to get, which is the same as if you add 5 twice, add 6, add 7 twice, add 8 3 times, add 9 4 times. If you do it the same way, you are going to get the same 90. But the f of x makes it easier, because the frequency will be large numbers, they will not be simple numbers. So if the mean is the sum of the figures divided by the total number of them, so there are 12 numbers in all. That's the summation of summation f. There are 12 numbers. So the 12 numbers, when you add them, you get 90. So 90 divided by 12 is what will be our mean. So the mean is summation f of x, which is at the top here, divided by summation f. So you have 90 divided by 12, and that gives you 7.5. 7.5. So 7.5 becomes an average. Is a comfortable number for all of them. Any question about this before I move it? Any questions so far? Confused or convinced?
Please, I'm confused here. Please, can you go over?
Sometimes it's nice you are specific. When you are specific, then I know where exactly your problem is. If you say the whole show, I'll go over the whole show.
Yes, please.
Still using these simple numbers to explain it, so that when you get it bigger, the calculation will not be difficult for you. You cannot just add 5 to 6 to 7 to 8 to 9 and divide by 1, 2, 3, 4, 5 and tell me that you have calculated a mean. No. The frequency you are seeing here is telling you that in that data, 5 occurs twice, 6 occurs once, 7 occurs twice, 8 occurs 3 times, 9 occurs 4 times. So instead of adding them 5 plus 5 plus 6 plus 7 plus another 7 plus 8 plus 8 plus 8 plus 9 plus 9 plus 9 plus 9. Before you divide by the total number of them, all the numbers I just mentioned will be 12. Before you divide by 12, just go this simple way. 5. How many times did you occur? You occur 2 times. We are still doing the additional. You know, addition and multiplication, they move together. So 5 plus 5 is the same as 5 times 2. 5 times 2. So we have 10. 6 is only 1. So 6. 7 plus 7 is 14. It's the same as 7 times 2, which is 14 here. 8 plus 8 plus 8 is the same as 8 times 3. 8 multiplies itself 3 times, and that gives you 24. And 9 occurs 4 times. Multiplying 4 gives you 36. So since we are adding, we only added 5 separate, we have 10. 6 separate, we have 6. 7 separate, we have 14. 8 separate, we have 24. 9 separate, we have 36. So now we have to add all of them again. So when you add 10, 6, 14, 24, and 10, you are going to get 90. What we what? Summation f of x. This sign means summation. Sigma, summation f of x, meaning f by all the products, and you are getting 90. Here means summation f. It means add all that the f, all that under f, add them. When you add 2, 1, 2, 3, and 4, you are getting 12. Here, when you add summation f of x, means add everything f of x. That gives you 90. So we already know that to get the mean, you add all the numbers and divide by the number of them. So the same thing here. We had 9 numbers, 12 gives the mean. Convinced, confused. The one who asked the question, are you okay now? Get better. And like Prof said, all the questions you'll be having, we'll just go along with these ones. I can repeat the same question and only change position for 3 and 4. So when you see it and you think, oh, this one is in the notes, you manage to go and pick the notes. For at the end of the day, you have the same mean, but some other questions that may come, you may not get it well. Or continue.
Continue.
Thank you. So median. The median is the number or the value that is found at the center of the data. When we arrange the data order of magnitude. When I say we arrange the data in order of magnitude, all I mean is we arrange the data from the smallest to the highest, or from the highest to the smallest, the biggest to the smallest. When you arrange the data in that order, the one that will occur at the middle, the exact center, that's going to be your. When you see these numbers, they are not arranged. To arrange them, 2 will come first, followed by 3, followed by 4, followed by 5, and by 6. Then we have arranged it in order of magnitude, or in ascending or descending order. Then we look at it. The one at the exact middle is the median that we are talking about. So involve first, when you have the data, you first arrange the data in that order of magnitude. Then the one at the middle becomes your median. But the question is, when you have a large set of data, are you going to be counting? Fine, you can do that one. You can test it. But that whole process of looking for the number at the middle can also be done in a way. Now, find the median of the following numbers. We have 2, 1, 5, 3, 7, 9, 14. So the first step is to arrange in order of magnitude. So when you arrange the same numbers from the smallest to the biggest, we are seeing 5 at the middle.
If let's say 3 and 5 is found to be at the middle.
Okay, we are getting there soon.
Okay.
So he's asking, what about if there is no single number at the middle? Or what if there are 2 numbers at the middle? We are getting there very soon.
Thank you.
That answers your question. What is the median for the data below? We have 6, 5, 11, 16, 3, 2, 4, and 2. So we are rearranging the numbers. We have 2, another 2, we have 3, we have 4, we have 5. We have 6, we have 11, and we have 16. It's arranged from the smallest to the biggest. So which number is at the middle? There is no single number. We'll draw a line between 4 and 5, which means both numbers are at the middle. So what do? We find their average. As for average here, it's going with us. We find average for them. Average means you add them and divide by the number of them. So there are 2 numbers, 4 and 5. You add, you have 9, and divide by the number of them. There are 2 numbers, so 4.5 becomes your median. The one who asked the question, are you answered now?
Yes, sir. Yes, sir.
Okay. Any other question?
So, Doc, hello, Doc. Please, can we get or can we have 3 numbers being the median or more than 2 numbers?
No, that is not possible. It's either 1 number or 2 numbers. If you have 3 numbers, 3 is already odd, so there should be 1 at the middle. If you have 1, 5, and 7, there are 3 numbers. Assuming you have 1, 5, 7, they are already 3, so 1 of them is at the middle. So you go for the 1 at the middle. It's either 1 number or 2 numbers.
Hello, Doc.
Yeah.
Yeah. I'm confusing here at the median. I could see the 4 plus 5, and then the down is 2, and the 9 down is 2. The 9, where do we get this 9 from?
The 9 is addition of 4 and 5. The 2 numbers in the middle.
Good. You can see the equal sign.
How about the 2 that is under? That is the 2 that is in the front of it. Or...
Because it's 2 numbers that we added, we divide it by the 2 numbers.
Oh, thank you very
So
much.
I already said you find the average of the 2 numbers at the middle. You find the mean. What did we say? The mean is what? is found by adding the values of the data and dividing by the total number of values. Here we are adding only 2 numbers. So we will divide by 2. We are adding 2 numbers, so we will divide by 2. So which numbers are we adding? 4 and 5 at the middle. So 4 plus 5 gives you 9. 9 is there. The 2 at the bottom here is the same 2 we have repeated. So 9 divided by 2 gives you what? 4.5. Any other question? Any other question?
No, please.
So these examples are for you. You will try your hands on them. And when we meet next time, you give out the answers, we compare. And don't be surprised to see some of these things in your mission or in your class exercise. I told you the class exercise will be online and it will be time bound. Once you open the link, you have to be online and finish before you go. And when it's time, it will close. So you'll likely see some of these things. Mode. The mode is the value that occurs most frequently in the data sets. If we have a data set, when you look at this one, every number occurs once except 2. 2 has occurred twice. So when you are asked what is the mode for this data set, 2 is the mode because it's the only one that occurs most. So any data set you have and a particular number occurs several times than the rest, that number becomes your mode. So when we had data on we had data on malaria, fever, TB, and those things. I think malaria had the highest frequency. Malaria had the highest frequency. That makes malaria the mode of that data. So the question that somebody asked, whether we can have 2 median, 3 median and co, that question is applicable here. There are instances where you have more than one number occurring most. You can have a data set and 4 will occur, example, 4 will occur like 10 times. And 6 will also occur 10 times. All the rest occur less than 10 times. So, because 4 and 6, both of them occur highest, the 2 of them are the mode for that data set. And we call that kind of data bimodal. We say the data set is bimodal. It has 2. Bi means what? 2. It has 2 modes. If there is only one mode, like we have above here, there is only one mode. The mode is 2. This is unimodal. Unimodal. In case you have more than two numbers as the mode, that becomes multimodal. Multimodal. Any question about the mode?
So please, doctor, please, the modal and the mode, which one is the best? When you come across a modal number or mode, I think is there anything different?
Mode is a noun. Modal is an adjective. So we are saying modal because they are more than one. So we say the data set is multimodal. I don't know how you are getting this. All we are saying is if you have a set of data, your data can be the systolic or diastolic values of your patients. And maybe you want to be specific, hypertensive patients, the systolic values. You are interested in the systolic values. You want to do an analysis with the systolic values of the BP of your patients. And at the end of the day, you realize that a particular number among the systolic occurs most. The systolic is the top one, right? So maybe 135, somebody has 135 on 80, 135 on 70, 135 on 100, 140 on 100, 140, 110, all that kind of thing. But you're interested in only the numerator, the top one, the systolic. So you realize that 135 occurs most. You have 135 occurring several times, more than the rest. So that 135 is what we are referring as the mode of that data set. And if it's the only number that is occurring highest, then we define that data set as being a unimodal. Uni means what? Unit, one. Unimodal. But when you have two numbers occurring highest, and I just mentioned 4 and 6. Okay, so let me use the systolic again. Maybe 130 occurs 15 times, and 142 also occurs 15 times. So because 130 occurs 15 times as the highest, 142 also occurs 15 times as the highest. When you are asked what is the mode for that data set, you are going to quote 130 and 142 as the mode because the two of them occur highest in the data set. And we are referring to that kind of data as having what? As being what? Bimodal. And I'm saying bi means what? Two. Bimodal. The modal there you are seeing is just an adjective. Is adjective derived from the word mode. I hope I've explained myself enough.
Yes, sir.
Yes, sir. But sir, are you using a earphone or what? Sometimes you are going up.
Oh, seriously?
Yeah.
Oh, no, nobody drew my attention to that. No, I'm not using earphone. I'm in office still, and I'm shouting loud. I think it should be my PC
Okay.
that should be having that challenge. Anytime I'm going low, draw my attention so that I will see what I can do.
Okay, sir.
Yeah. Okay. So when the data set has several modes, we say is multimodal. And if there is no mode, like this one, where are you? Yes, when you look at this data, all of them occurs once. Each number occurs once. So there is no mode. There is no mode. The data has no mode. So we have instances where there is no mode. We have instances where the data will be modal. We have multimodal. Okay, find the mode of the signing bonuses of 8 MPs for a specific year. The bonuses are in millions of cedis. We have 18 million, 14 million, 34 million, 10 million, 11.3 million, 10 million, 12.4 million, and another 10 million. Which one is the mode here? Which one is the mode?
10 million.
10 is the most
million.
occurring. 10 million.
So we are having 10 million occurring here, occurring the second time, and occurring the third time, whereas all the rest are occurring less than 3.
So there's 1 year, the person is making has omitted himself and is making a lot of noise. Ye,
Come again.
I'm saying there is somebody identified himself as ye, and he has omitted himself and there's much noise at the background.
Oh, okay.
So the host to omit the person, please.
Can you let's be tracking this people? If I want to be moving back and forth like that. Good. I think I've managed to mute everybody now.
Thank you very much.
Okay. So we go. We have another one. Find the mode for the number of health employees per region for 10 selected regions. So in one region, there are 110 employees. In another region, there are 731. Another region, there are 1,031 employees. Another region has 84. Another has 20. Another one has 118. Another one has 1162 and 1977, 102 and 752 number of employees in the 10 regions. What is the mode for this data?
There's no mode, sir.
There is no mode.
So there is no mode.
Thank you. The end for that. Any question? We still have more time.
Hello, sir.
Yes.
My hand is up. I'm Kingsley Kayameboji.
Okay.
We so much appreciate the way you have taken your time and given us the stuff. But I would like to plead with you that you let us have the slide as early as possible so that we can go through. If at all, I don't know how you feel, but if you can send the slides even ahead of the presentation, we can go through and get ourselves updates with what will be ahead of us. Thank you.
That's fine. Having the slides instantly, just after the lecture, It's highly possible, but in advance, it's not advisable. Student will go and read it. So this one, I know already. So when I read, I'm getting it. And they will
But so at the same time, you can find a means of ask, maybe short introduction will let you know if you are in class or not. Because of it's a plea I'm making because of the way some of my colleagues are complaining of their age and the time they left the classroom and others. So if you can have it ahead of time, I think it can go a long way to also help you because look at the back and forth in this presentation. So let's see how best we can go about it. Thank you.
All right. We'll see how it goes. Yeah. Yeah. Any other issue? Any other concern? Any other suggestion? Any other question?
Doc, please,
Sure.
can we go back to the cumulative frequency again so that we can revise on it?
I'll go there. I want to take my time. I was going to talk about it so that we draw a curtain on it. But I realized we just have to go systematically. So don't worry, we'll get to cumulative frequency curve. Don't worry at all. Are you okay with this one?
Yes.
Please.
The next slide is only 4.
Okay, so I'm asking that should I
Yes.
continue, please?
Yeah.
Okay, so for the question 2 for the mode, does that mean it is multimodal?
Question 2.
He's asking about the one without any mode.
Yeah.
No, there is no mode at all.
Okay, so there's no modal.
Yeah, there's no mode. There's no mode at all.
Okay, your voice is far.
Wow. Is it better off?
Yes.
There is no mode.
Okay.
There's no mode, so it's as simple as that. Even if all the numbers occur two times, or they all occur three times, 4 times, because they all occur the same number of times, there is no mode. But if
Okay.
1, 2, 3 or more of them occur higher than the rest, then we watch out for the one that occurs most. If it's only one number, there is unimode, and that single number becomes. If there are two numbers that occur the same number of times, then there are two modes, and we say bimodal data. If there are 3, 4, 5 that occur the same number of times, then we are saying it's multimodal.
Okay.
Multimodal. That's all we are trying.
Your voice is very far, but I've gotten it. Thank you.
Oh, I don't know. I realized that when we're in a Zoom meeting too, when I'm asking questions at times the same complaint comes. I think I just have to get some experts to look at it for me. Yeah, is there any concern? Anything we can talk about? Okay, if no question, then let me give you a sleeping tablet.
Okay.
God
Okay.
bless you.
God bless you,
for
sir.
your
Thank you so much.
exercise patience. Okay, Dr. Freeman, thank you very much.
It is a pleasure.
Thank you,
Okay,
Doc.
so let's see.